Hi guys, Jared with Cooler Bleeder. Today we're going to be using my personal C7Z to give a demonstration of the Cooler Bleeder, how it functions, how you actually integrate it to the car to get the air out. And what I've found, I've struggled with this. I've had several prototypes that I've made through the years trying to get air out. I read on the forums about all you guys having the issues. Using the proper ZR1 tools, there's several members that, hey, I went to the dealership and they had the car sitting at 45 degrees and they spent 4 hours on it and I still have an inch of air in the reservoir. What's going on? Well, what's going on is, quite frankly, the factory tools just don't work. Using a pneumatic bleeder does not create enough suction to get the air out of these cars when they're very, very air trapped. There are some cars that are not as problematic as these. This tool works for those too. It may be a little bit overkill in some circumstances, but at the end of the day, it works for everything. The concept is basically putting enough suction and vacuum force on the car that any kind of air pockets that are there greatly expand. So the more vacuum you put, the bigger those air pockets get. And as they expand, any kind of little traps or hooks in the charge air cooling circuit, they'll break free of them. And then we're going to use the coolant pump that is built into your car to actually flush those pockets out and out of the system. So kind of a breakdown of just basically how this works. But again, today we're going to do a C7Z. First things first, key should not be in the car. Ignition should not be powered up. We don't want any kind of power to the fuse box or otherwise other than just battery voltage. Brings me to my second point. If you have a battery charger, it's a good idea to put it on the car during this bleeding process. Most of these pumps only pull 5 to 7 amps on average. ZR1, like C6 and stuff is going to be one of your higher ones, pulling close to 20, I believe. But regardless, they can quickly run down battery during this process. The bleeder unit itself also uses voltage to run all the status lights, to run the switches, to run the vacuum control solenoid. So there is a big drain on the battery. If your battery is totally healthy, it's going to make it through. It's kind of going to be fine, but I'd always rather be safe than sorry. So if you got a charger, hook it up. Step 1. Keys out of the car. Step 2. From there, our next goal is to get our chamber higher than any other part in the system. And we want our suction hose to have a gradual upward slope to the chamber itself. So I don't want to see a big kink or a U-shaped in it. Every car, depending on, in your Corvette world, C7, depending if you got the short lid, the tall lid, you got the NX lid on it, or Weapon X or one of the other ones, you've got all sorts of different heights. Regardless of which one that's on it, I'd like to get it up even higher. So start by putting down a towel. This is just going to prevent any kind of scratches or cosmetic damage. I'd always rather be safe than sorry. You're going to see on that side, that fender has got a fender cover. You'll see why here in a couple minutes, because I'm going to be running hoses and tubes up and over the fender. We don't want any kind of damage. So from there, spacer, I'm going to use a good old cardboard box here that just came in the mail. And then put the tank on top. Our bleed point is down here at the quick change coupling. That's where we're actually going to interface. Every car has a different point, or every style of car. So C7Z06, it's we're going to go right through here. Cadillacs, a lot of times those are going to be done through a similar style system, or a bigger adapter, or through the reservoirs. The key to all of this, and I'm going to reference it several times, is the chart. I spent so much time on this. It's the gateway to how to bleed any car that the adapter has been made for. It's going to tell you your fuse sizing, it's going to tell you your connectors. If you go online, it's much easier to read because it's expandable. There's also a ton of pictures, so it's going to give you a nice picture of the engine bay of your model, a red circle around here. This is where we're bleeding from, just to give you a good idea. So this is key. There'll be one in the manual. There's also one online that will be continually updated. Reference it. So on a C7Z, what we're going to be using, the adapter is the QC1. QC for quick change, 1 because it was the first quick change adapter that I made. And that is going to adapt right here on the car. But first things first, we need to do a couple other setups for right now. All right, so our next step is going to be actually getting the lid onto the pot. There's no coolant in here. We're not hooked up down here at the quick change connector yet. This is just our preliminary step so that we can actually calibrate this unit to your individual vacuum pump. All vacuum pumps are a little bit different, and we're going to show you how to set that up to start with. So This will be already assembled, hopefully, by you. If you have not done the assembly, then you need to go check out the assembly video, and they'll show you how we get to this point right here. But for the time being, we are going to set this on. I'm going to try to get it so that you've got a good view. So we're going to set this lid assembly on, and next step, we're going to have to connect the 1/4-inch SAE flare to our vacuum pump. So this is our 1/4-inch SAE flare. I have my vacuum pump sitting over here with just some various adapters. This charge hose does come with the unit. So we're gonna run it up and hook it up right here. These are all finger tight connections. So as we go through, they do not need a lot of torque. You do not need a wrench or tool or anything else along those. Just a nice snug by thumb. The other side on your vacuum pump, this is the Robinair, which is kind of the Rolls-Royce of home units. Maybe even a little bit of commercial use is available for purchase from our website if you want it. Does a great job. It is absolutely overkill for what we're doing here, but if you're doing other heating and air conditioning work, it's a really, really nice unit. So we're going to go to the flare fitting here. That's already been tightened down. One other note on vacuum pumps, they exhaust the gases that are being brought in through these caps. They smoke. Every single one of them does it. It is totally normal. We're not going to run it a whole lot because you see I got the garage door shut, but if you're running it in a closed area, it's going to create a fog. A lot of times you'll actually see a drain of oil kind of coming down too, which is why I've got a towel under this. Last step, make sure you've got oil in your pump. You will have a sight that kind of shows you your oil level. Want to make sure that stays full from the oil that's lost through just general misting. All right, so our next steps are going to be actually integrating the suction hose onto the car. First thing, if you have an aftermarket tank, as such on this car that is fillable, they are not all fillable. It's a good idea to go ahead, take the cap off, and fill it to the absolute brim. And what that does, that just gets rid of a lot of the air that has to be bled out. Now, if you don't do that, what happens? Nothing. The machine's going to take out that air, but you're going to have to stop through the bleeding process and add some more coolant to it. So just it adds time. When it's really easy to fill, just fill it to the brim. Now, I understand a lot of the manufacturers tell you do not run them at full capacity. They want the coolant level down a little bit. So in this particular case, that's going to be the case here. You see the threads and stuff, you know, we're not touching coolant. It's just barely covering the hose in. For demonstration purposes, you kind of see how this works. I'm not going to fill this because we'll come back here in a minute and you'll get a very good demonstration of how it takes out that air in the system. But for all intents and purposes, fill that all the way up, reinstall the cap back on, tighten it up, and kind of go from there. The next connection, again using the vehicle connection chart, this is where we're going to bleed the C7s from. I've got the Series 2 adapter already installed on the end of the suction hose. These are just little twist fittings. So they don't unthread, but as you turn, you'll see a little bit of free play. There'll be some resistance. And in that point, you can kind of wiggle them and they're just going to pop right up and out. Don't lose this. All right, so now that's removed, we're going to go ahead and use the QC1 connection. In this particular case, it literally sits up there. Push it down, it's attached. You're going to see it's not going to come back out. To remove it when the time comes, it's going to do that rotate until you get a resistance, find the sweet spot, and it's going to pull right back out. For now, snapped in place. Series 2 adapter. In order to put these adapters on, there's a collar. This is true in the Series 2 and the Series 5 that you pull up. It's much like an air chuck fitting, but these are leak-free, where an air chuck fitting would not be. So we're going to line it up on top of the fitting, pull up on the collar, push down, and it is snapped in place. So before we go any further with the Z06 today, I wanted to give you a feel for what other adapters are available and how we would utilize them. So obviously if you're doing a car other than a Corvette, you know how these fittings work. So everything is based on these quick change couplers. Like I showed you the Series 2, this is the Series 5, which is bigger. It's identifiable by the green collar on it. But regardless of which adapter we're using, we're going to have these fittings. And everything is based off the Series 2, the smaller. So whether we're using the reservoir adapter, this is the Res 1, the Cap 1, the GHT, those all adapt to a Series 2, or of course the quick change one, QC1 that we were just using on the Corvette. Operation of the Series 5 is going to be just like the Series 2. So hypothetically, if you've got a Camaro or the Cadillacs that take that style adapter, the nipple's already going to be built into the car. So rather than having something like this on the adapter, you're going to go directly to the car. These were special ordered, custom made for me per se by the company that's making all these fittings for General Motors. This is not an off-the-shelf fitting. I apologize for the price. It is what it is. It's half price of the GM tool still, but it has been made with the shorter 3mm depressor. So I know a lot of people are worried and concerned about that. This was made to those specs. It is going to operate just like the Series 2, where we've got this collar that pulls back, in which case it just snaps onto your fitting like this. So these are going to go, again, the collar comes back, push onto the connection, and it's going to seat. There is no getting it off. There is no leaking from there. Removal is going to be the same way. From there, put your protective collar back on, and you're back together on that style fitting. So if you take the Series 5, that's how that's going to connect. Again, use the reference chart that provided. The connection chart will show you what's needed and what's being done. Quick run through of some of the other ones. This is our Cap 1 adapter. This is a non-vented cap. So there again, it takes the overflow out of the equation. But we're going to use this on a lot of the Fords, the GT500s, the 0304 Terminators, the Lightnings, etc. All can be bled through this style cap. We have, this is our Res 1, Res for reservoir plug, several of the Cadillacs, the Cobalt SS, the Saturn Ions, Redlines are all using this style connection. And on those cars, just get a quick feel. You'll have a reservoir that looks like a T, as this does, and this just plugs in. So again, you want to put on the O-rings a little bit of dielectric grease, silicone grease, just like the suction tube when it's assembled. It's going to go through though. You remove your factory cap, and it just pushes in. And you're going to see those O-rings through there. Both the sealing O-rings are below the level of the overflow. So the factory manual tells you have to pinch off or clamp that overflow line. That is not necessary with this. Where it's sealing in the tube is below this, so absolutely no need to do anything with this line, disconnecting it or otherwise. Removal is going to be the same thing, just kind of a quick pull up, comes out, and you can set your factory level at this point, because when we're done bleeding, it's going to be totally full to where it's supposed to be, and put your cap back on. The last style fitting that I want to show you today, other than the quick change, which is C7Z06, C7Z01, LT4, and I think the Cadillacs use this one too. Again, use the chart, it's going to be accurate and correct, but this is what we're using today. The other one I want to show you though is our universal. We've got these T fittings, so if you don't have a bleed port, you've got a muscle car that you've retrofitted in, you've got a special setup or whatnot, these adapters can be teed in. You want to put them in the uppermost hose, so you want to get as high as you can. They're available in 1/2 inch, 5/8, and 3/4 inch barbs. They don't come with hose clamps, so use whatever clamps you want, but they are designed for coolant, so they'll withstand the heat. And they basically are a garden hose type of setup. So if you have a hose and you want to flush your system, you can do it through here if you want. Or in our case, we're going to be bleeding with the GHT adapter. So this will screw onto there. You can do your bleeding, put your cap back on, and you kind of can retrofit a bleeder into the vehicle if you don't have a good spot to do so. All right, so our next steps are going to be actually calibrating the valve assembly to your vacuum pump. So what we've got here, we've got two valves. This bottom one, what I call the horizontal valve, is the pump control shutoff. That limits any kind of flow coming from your vacuum pump
the suction, you can cut that off. So in an emergency case, when I say emergency, you've got coolant levels that are rising rapidly and they start to risk being ingested into the pump. You do not want that to happen. So if you see that, you need to shut this valve. The valves are marked, but like any ball valve, if the handle is going perpendicular to the setup, that valve is closed. If the valve is parallel to and in line with, that valve is open. So during any kind of normal operation, we want that valve fully open and in line with our charge hose. Our charge hose. Our other valve is this vertical one. It operates the same way, but this is our calibration valve. This is how we ensure that when the vacuum is being released in the system, that we have a really nice controlled flow, and that we never get too low on our vacuum pressure. So in order to set these, we've got the lid on, as we said. We're going to turn on the vacuum pump. And hopefully here you can hear me over that. I'm going to speak a little bit more loudly. So our vacuum pump is running. You're going to notice in here that we're already pulling out some of the air. That's coming from that pocket of air we were looking at before in the accessory reservoir. That's one of the reasons why I wanted to avoid that. But again, it's not the end of the world. You're just getting coolant start to pop out. What we're going to do, we're going to use this calibration valve here to try to stabilize our vacuum pressure. This is not an exact science, but you're going to start to shut this valve. And as we shut, you're going to see the vacuum start to rise. And we want to stabilize this. So by opening and closing it, somewhere around 7 inches or so is about perfect. It's not an exact science. It doesn't have to be. If I were to shut this valve more, you're going to see the vacuum really start to rise. As such, we don't necessarily want that. If I open it too much, we're going to be falling. So again, depending on your pump, these are all going to be set a little bit differently. But we're aiming for about 7 or so, as far as a nice stable pressure. So that's where we're at. And again, you're going to see the setting. But regardless, as the pump continues to run, the vacuum is not changing. That is our low set point. As a note here, we do not have anything hooked up. There is no power to the unit whatsoever, and that is how we have to set this initially. All right, so now our calibration is set. Our next step is we are going to turn off the vacuum pump, which I've already done. There'll be no vacuum in the system, nothing's plugged in. Just remove the lid, and we can look in this chamber. What we're going to do, we're going to add coolant to this. That little bit that's in there is what started burping out when we did the reservoir from our initial apply. But we're looking at the black uniseal fitting down there, and I want to put coolant level to above that fitting, roughly an inch. It is not Dex Cool in this fitment. You want to use whatever the manufacturer specifies or whatever you're using for your individual system. So we're going to add here. All right, and that's where we ended up. Again, not an exact science, no need to be. And then at this point, we are going to take the lid and put it back onto the top of the unit as such. So our next steps are going to be actually getting our blue pump control wire hooked up to the vehicle, which is this. This is what is going to interface to the vehicle electronics and run the factory pump. So again, locations and tap points are all going to be in our vehicle connection chart. On the C7Zs though, we're getting to the fuse box under hood. And we are going after this fuse right here. It's a 15 amp fuse, and that needs to be removed. And now at this point, the end of our control wire is going to insert into the fuse block here. Now there's two legs. There's a forward one, there's a rearward one. I can't tell you which one it is because every car is going to be a little bit different. On the C7s, you need to go in this back location. If you put it into the wrong one, we can address that later on. But as of right now, we're just going to put in the correct one. It slides in. There's nothing more to do from there. So one of the things that the hookup chart does not tell you is which adapter to use. This is all going to be dependent on what your fuse style is. So this car, we used we pulled out a mini fuse. You're going to see the spade on the end of the pipe pump wire is the same sizing as those spades, both in width and depth per se, or the thickness of the spade. If you remove the bigger style fuses, some people call these regulars, ATO, ATCs, these don't line up. This does not work in this style. So for that reason, attached to the power harness, you will have two adapters. These adapters get to different sizes, or if you're controlling a relay, will help that out. And the difference between these two adapters, one's going to have a yellow tab on the end, the other one's just strictly blue. And the difference, and I don't know if you're going to be able to see it, is the thickness of the tabs. The one with the yellow is a significantly thicker tab. That's going to be used for relay replacement. The thinner one, which is just a blue connector, is going to be used for fuses. So if you pull out the regular sized fuse like this, you're going to use the blue tipped one. If you are adapting to a relay, in other words, you pull a relay out of the car that looks like this, you're going to use the thicker one with the yellow ring on it. There are some mini relays that have a significantly narrower tab. Those are just going to connect straight to the pump wire with no adapter needed. The adapters, though, are simple plug and play. So you take the tab, plug it in here. It is possible to bend this. You want to be very careful as you kind of wiggle it in. Wiggle it left and right, and it's attached. When it's in, don't let this arc against anything. There is a little bit of exposure there. But now you have the thinner tab if you need to go to the regular style fuse. Removal, same thing, just a little wiggle, and it's going to be removed. Both of these are included in the power harness. There's a pouch, they'll be there so that you don't lose them, and you can use them as needed for different fitments. The other thing that we need to make sure that we do at this point is by using the connection chart. Here's the pouch I was mentioning before, is put the correct fuse in the harness. This fuse not only protects the cooler bleeder circuitry, it also protects everything on the car because we've removed the factory harness, or excuse me, the factory fuse. So they come pre-installed with the 20 amp. That 20 amp is the max capacity of this system. So if it requires it, it can handle it. You do not want to use a 20 amp in a car though that I tell you needs a 15 amp or a 10 amp. So install the correct fuse into this socket. We're going to put a 15 amp in this. Just pulls out as such. Take the 15, plug it in, put your cap back on your power harness, and now it's set and protected for 15 amps, which is what our vehicle today takes. All right, so we've identified the terminal that we want, and as a hypothetical, let's say this where it was unplugged from on the car, and we want to go to pin 87, which is this terminal right here. You need to see how this relay would interface with the harness. So we're going to rotate this here, and it goes down and in. It's going to plug in like that. So this was pin 87. This would be the hole or the insert that it's going into. So as we are tapping this, we want to make sure that we are using this location right here where pin 87 would plug in. That's the rough rundown of how relays. This is very, very vital. Unlike the fuses, you don't get a second chance at this one. It does matter, so don't install it into the wrong slot. You can damage things. So we're back at the car. We've got our fuses in. We still have our pump control wire hooked up. Our next steps are getting power to the cooler bleeder unit. We do want to make sure that the switch on the unit is in the off position before we do this. And we're going to take our clamps here. We need a positive lead. Red is positive. We need a good engine ground or battery ground, which is going to be our black. That's going to be up to you to determine. If you want to go directly to the battery, you can, or if there's another point that's easier to obtain, that is also perfectly fine. We do need to make sure that we've got good connections though. There's a fair amount of current going through these, so if you don't have a good ground location, it's possible that our unit doesn't work. Typically in that case, what I've found is you end up with a light that works on the control box, but you don't actually get any kind of vacuum changes, and the pumps won't run. So on this car, we've got, if you can see right there, the little red tab, that is a positive battery post. So that's where we're going to connect our red cable, which is battery plus, to that. You always want to start with the positive. Your black ground, again on the C7s, the really easy place, which is a good engine ground, is just go directly to the alternator here. It's bare metal, grounded very, very well. So that's our connection point. All right, so we're back at the car and ready to start the bleeding process. We've already verified that the pump is running when we plug it in, so we know all of our connections are correct and good. Calibrated the valve. Go ahead and turn this on. You're gonna see our blue status light lights up, let us know the pump's running. And we're gonna turn on our vacuum pump. And we're gonna see that vacuum start to rise to that set point that we did before, which is gonna be about 7 or so. And at this point, you just saw it click over to yellow. Yellow means that we're going to be under extreme vacuum. If you look in here, all that bubbling and disturbance is air being removed from the system. You can also see it shooting up the hose here as it suctions. This is the only step that has some urgency. You need to make sure that that level never rises to the point where it's going to get in your valve assembly. That is very bad news for your vacuum pump. If it gets close, this is what this shutoff valve is for. Shut it, that will cut off your vacuum pump. You can turn off the pump at that point and kind of start back over, take a little bit of the coolant out and go from there. So we're still under vacuum right now. You see the yellow lights lit up. We will cycle here in a minute, and what we're going to see is the blue light come on, which means we're no longer actively applying vacuum. Our gauge is going to drop down and we're going to cycle. So there's our cycle. Vacuum is dropping. And right now the pump is cycling the system. So the combination of that vacuum applying and releasing at the same time that the pump turns on creates a surging effect. And that surging effect helps flush out any kind of air pockets through the system. And we're under vacuum again. And at this point, you're going to already see that there's not nearly as much bubbling going on. So those little bubbles are definitely still air being taken out of the system. That's dissolved air that was somewhere in the system. But we don't have those large pockets anymore. Again, those large pockets all came on this particular car from the accessory reservoir on it, where we left that air gap. And there's really nothing else that you need to do. We can just sit and watch. I'm going to take a step back here to give you a general feel. The car is totally level, so we're not doing any kind of abnormal slopes or incredible angles that we're putting at to get it to bleed. This car is going to bleed very, very quickly because the main reservoir has been done already. I've used this tool on it several times in the past, so it's not going to take a whole lot. But what we're watching for completion is when under full vacuum. So as the gauge is rising, we want to make sure we're above 25, 26 inches. We're looking down here, and if there's not a whole lot of air bubbles coming out anymore, so we can still see there is some. once that dissipates and we're not getting big burping, we're not having anything shake in the hoses, we don't have large air pockets in the hose, we're totally full all the way throughout, then our bleed's basically done. C7s typically are about 15 minutes or so worth of run time to get all the air out. A lot of the other cards we can get done in 10 minutes or so. Absolutely no harm in letting this go as long as you would like. It's just going to continue to run the pump and pull out air. So again, we see the bubbles are greatly reduced from where they were before. And there's another couple pockets just pulling back up. So we'll let this run a couple more minutes, and then I'll show you the procedure to disconnect everything. All right, so we're back here, and we're currently got the pump running. It just switched to vacuum. What I like to do at the very last cycle, as I'm getting ready to take this off, is go ahead and shut this valve totally. And what that's going to do is disable the system from having the ability to release vacuum. So we're going to let this run. Typically they're going to vacuum for about minute cycles, give or take. We're just going to let it totally build up as much suction as this vacuum pump can handle. And that's going to get any last little bit of air in this line out. You will see at times, especially in this last stage, you'll get an air pocket here, or this very last section of hose will have an air pocket in it. While it's doing this, just pick up the reservoir and put an extreme angle on this and let that air pocket fill with coolant. The air pocket will want to kind of rush up and kind of cycle out of the system. We're looking at it here. See, the pump is running, but we are not dropping vacuum because this valve is shut. So the pump's running. See it circulating through. We're getting absolutely no air out. No air in the hose. So we're doing very well here. How to disconnect. You do not want to turn off your vacuum pump while there is suction on it. You will siphon all sorts of stuff into it that you do not want. And actually, we did just pull a tiny bit more air out. I don't know if you saw that last little bit of air come through, but so what we're going to do, we're going to start with shutting off this valve. Very important. Shut that off. We are going to turn off our vacuum pump. A little bit quieter now. And at this point, we can take our valve here and open it. You'll notice nothing's going to happen because right now the solenoid is blocking any kind of flow. And we're going to let it cycle. And when it cycles, that coolant is going to rush back in to the reservoir, filling any of the last voids. We do not want to disconnect anything else at this point. There it is. And the pump is running. We're going to hit 0 vacuum. Totally. Take a look down here. We are lower now. If you notice, it's hard to see. I'll show you here in a second though. And the pump cycled on. We are totally done at this point. You turn it off and do your disconnects. So this fitting can come undone. And our power at this point. So we want to go in inverse of what we did. Ground off, power off. This can be removed. Now, a very important step that people love to miss is we need to put the factory fuse back in. If not, you do not have a pump that works. So take the fuse, put it back into its home. If this was a relay that we were tapped into, same thing, put your relay back. The fuse cover can go back on at this point. Our lid assembly can be removed. Again, we're totally disconnected. I'm just going to set this for here right now. This is going to give you a better view. If you recall before, we were about 1 inch above that fitting. So that's how much coolant the system actually took. The majority of that is going to be into that expansion tank realistically, but you can calculate how much air was in the system based on how much coolant is actually used. One thing I did not cover before, if you've got a lot of air in there, keep an eye on that. If the coolant level drops too far, the system won't have the ability to refill itself. So you'll have to pause the bleeding process halfway through, add a little bit more coolant to it, and top off again. That was not necessary in this case, but I'm going to try to show you the factory reservoir as well. As we look down here, that's always a hard one to see, but as you kind of can tell, there's just two really, really small air pockets there, which is exactly what the factory wants to see. Rock around. So our connections now. This is the last thing that we're going to have to undo. The hose itself is valved, so you're not going to have any fluid loss from this fitting. However, this is totally full of coolant underneath there. So what I like to do so we're not making a mess is just go ahead and wrap a towel around the bottom of this fitting as such. And then we can go ahead and start the disconnect process. So again, this valve is going to be drip free. Just like we put it on, we're going to pull up on the collar as such and release like that. And at this point, this fitting is not going to drip, even though our hose is totally full of coolant. What we saw come out of there is just the little bit of residual pressure in the system kind of burping back up. A real easy way to do this is just kind of hang this on the chamber. Keeps it up and out of the way. And then we need to remove our quick change adapter. Same way we put it on, a little bit of a quarter turn and release. And you're going to see the coolant level is totally full there. And then we're just going to reinstall the factory plug. Snaps in place. And any kind of mess at this point, you can just kind of dab up, but it's nice and clean and drip free. As we said, that fitting up there is totally dry, which is really nice. Any kind of coolant that's left over, I'll show you a neat little way to get rid of that. All right, so now for kind of the visual update of what we just did. Total elapsed time, I didn't run this more than a minute or so. Like I said, this system was already fairly well bled. If I would have let it go the full 10 or 15, it probably would have pulled out a little bit more air out there. But take this off to give a representation. And you see it's already kind of spilling out a little bit on me because this is where our level is. So before I was kind of sticking my finger, you could see all those threads were exposed. The inlet pipe was right at the top of it. So just a quick example of how it's pulling air out of this reservoir. You can imagine though, the same is true. Let's say you had a low air pocket in the back of the intercooler bricks, up here, which is where these love to air trap. The same effect. Air is being removed from here. It's going to be removed from up there. If you do have a reservoir like this, it is very important now at this point that you siphon out that excess coolant with the baster, whatever it may be, and kind of get rid of it back into, I like to just turkey baster it back into the reservoir for right now, and I'll show you how to get rid of that. All right, so we're on the other side of the car. Reservoir, I have not bastered down the level yet. We'll fix that off camera. An easy way to transport this, just so it's not so unwieldy, is kind of put your series adapter just up through the handle. It makes it easier so it's not out and in the way. Again, it's not going to leak on you because of that valve fitting. So an easy way to kind of clean out what's left in our reservoir. So we do have some coolant there. That always has to be disposed of by your local standards, state, federal, etc. A lot of times your part stores will take the old coolant no charge for you. But rather than just trying to dump it someplace that it shouldn't be, a really easy way with these hoses is just take your old bottle. I've got our quick change connector that we were using here before, just on the top, and we can take this fitting and just snap it right on top. And as soon as we make this connection point, the entire pot's going to drain. I don't know if you can hear that slowly lift up. You can see we're draining. And that's just a real nice, easy way to let that sit here for a second, but kind of empty the pot out of anything that's in it. So the last steps are just really clean up. It's a matter of getting the pot, rinsing out with some fresh cold water, rinsing the lines, rinsing off the adapter. You want to keep that all clean. Coolant tends, if it dries, to leave a crusty film, so you don't want that building up in the unit. Everything's meant it can get wet. The only thing you really want to be careful with is that gray controller box and gauge. So rinse down along the base on is totally fine, but don't actually submerge those or get those wet. And that keeping it clean will go a long way in keeping the bleeder unit working for a long time without any issues. So that wraps up our tutorial today. Hopefully you learned something doing the bleed of the C7Z06. If you have any questions, don't hesitate to reach out, and I thank you very much for your time. Have a great day.